Here we are at our 4.1 number 2 set of notes looking at the 1.4 theorem proof. And I'm not going to lie to you, it's actually kind of confusing at certain parts. Some parts are actually going to make a lot of sense, some parts are going to be a little bit intimidating, but kind of the main thing that we really want to walk away from is the corollary that directly relates with them. But it's kind of nice to know where that corollary comes from, and it's based on this proof that we're going to talk about. If you don't understand it 100% all the way through, that's totally okay. But again, it's just really nice in seeing where does this corollary follow up with. Alright, so starting out, if we recall, we know that the derivative with respect to x of the natural log of x is equal to 1 over x. And we saw that back in chapter 3. And this is anywhere that x, provided x is not equal to 0. Otherwise, you'd have that undefined statement. Now we're going to go ahead and break this up into two separate pieces. So for anywhere that x is larger than 0, then we have that the natural log of the absolute value of x must be equal to the natural log of just regular x without the absolute value. And the reason for that, again, is because x, we're assuming that x is larger than 0. Now, just a really quick side example that shows this is if we were to plug in basically like x is 2. Well, x is certainly larger than 0, or 2 is certainly larger than 0. If we throw that in here, then we would end up then with the natural log of the absolute value of 2. Well, that's equal to the natural log of 2. And as a result, you can even just see the natural log of 2, absolute value of 2 is just that natural log, so in this case it's just 2, is equal to the natural log of 2. And as a result, if you think about applying the derivative with respect to x on both sides, I mean, if these are truly in fact equal to one another, then if we apply the derivative with respect to x on both sides, for this one we'll have the absolute value. It must be equal to the derivative of the natural log of x with respect to x. And that, again, just back from previous chapters, should be equal to 1 over x. So as a result, we can then basically assume then the derivative of the natural log of the absolute value of x is going to come out to be 1 over x. Taking this one step further, because right now we've only seen the case where x is larger than 0, let's see the case where maybe x is less than 0. Now this is where things get a little bit more tricky. I'm going to go ahead and erase this for a moment. Now we're working under the assumption that x is going to be less than 0. And as a result of that, we would have the natural log of x, the natural log of the absolute value of x is equal to the natural log of negative x. And the reason why this actually works is because if you think about an absolute value, we actually end up with two answers, a positive and a negative version of that. And that's actually why this holds true here. And that's, again, where x is less than 0. Well, just like before when we worked with the positives, if we take the derivative with respect to x on both sides, now this is where things actually get really interesting. On the left side, we should see that, again, just from our previous definition, that it should be equal to 1 over x. But on the right side, we see the derivative of the natural log of negative x. Well, if we think about the derivative of a function, or I'm sorry, if we take the derivative of a natural log of some function, we'll call him f of x right now. Remember that that's the derivative on top divided by the original function. So again, the derivative of a function on top divided by the original function. Well, let's go ahead and take that. Here's our function, negative x. So really we have the derivative of this on top. In this case, the derivative of negative x comes out to be just -1. On the bottom, we have our original function. Well, here's our function, negative x. And we see very quickly that our negatives end up dropping out. So in actuality, we end up then just with that 1 over x. So in other words, anytime that we have that x is not equal to 0, then the derivative for the natural log of x, in terms of the absolute value, is going to always be 1 over x. It doesn't matter if x is positive or negative, because again, we've seen both cases. Now, this is really where things are going to be applied for, this chapter, is taking this information and applying it to a corollary. Well, again, we've been talking about derivatives this whole time, but chapter 4 is all about antiderivatives. So as long as x is not equal to 0, so for x is not equal to 0, then working backwards with this definition, we can say that the antiderivative, or the integral, of 1 over x dx is going to be equal to the natural log of the absolute value of x plus some constant. Now, unfortunately, we don't always have just the natural log of x. A lot of times we have functions. In fact, this was a type of that, where we saw a function. And pretty much how do you get around that? Well, in short, we pretty much just apply a lot of the same rules, only instead of just x, we're throwing in an entire function. So for example, as long as f of x is not equal to 0, so before we just had as long as x was not equal to 0, but here we have the entire function is not equal to 0, and f is differentiable, so you can take the derivative of them. Then the derivative with respect to x of the natural log of the absolute value of our function is the exact same thing that we've seen in the past. It's just the derivative on top divided by the original function. Then we'll change colors, indicating that this is actually the corollary part, the stuff that we're going to use more this chapter. Then the antiderivative, or the integral of f prime of x divided by f of x is equal to, dx, is equal to the natural log of the absolute value of that function, f of x, plus some constant. So again, it's pretty much just working backwards. So we were taking the antiderivative of this, well, then it comes out to be this, plus some constant. And again, that's as long as f of x is not equal to 0. X is not equal to 0. So the big ones that we're going to use are this one, and this one. The proofs, I won't lie to you, you don't necessarily have to memorize verbatim, but they are kind of nice at seeing really where these definitions come from. But in terms of like an overall test, I would not expect that from you. Again, though, that is the Theorem 1.4 proof, Corollary 1.1, and the Corollary 1.2 proof, in really just identifying where do we see the integral, these integrals of natural logs pop up.